Hello everyone, welcome to Digital Communication Tutorials. In this video, I am going to discuss on time division multiplexing. Before I start the discussion on time division multiplexing, I would like to show you the waveform for flat top sample signal. You can also view this waveform as one generated by pulse amplitude modulation. An important feature of pulse amplitude modulation technique is the conservation of time. That is, as you can see in the diagram shown here, the transmission of PAM wave engages the communication channel only for the fraction of the sampling interval on a periodic basis. In simple words, PAM creates gaps in the sampled signal and the communication channel is void of any data while transmitting these zero amplitude regions of the PAM wave. Instead of wasting the channel utilization during these zero amplitude regions, it is possible to use this time interval between adjacent pulses of the PAM wave by transmitting other users' information on a time shared basis. By doing so, we can save the time that may be required for transmitting other users' information. This principle is called conservation of time, and this forms the basis for time division multiplexing. In a sense, we are combining information from several users, making sure the information signals are independent within one sampling interval. By doing so, we obtain a time division multiplex system that can transmit several users' information within one sampling interval, enabling the joint utilization of a common channel. The concept of TDM can be better understood by studying the block diagram shown here. At the input, we have n message signals indicating the presence of several information signals. Each input message signal is first passed through a low-pass pre-alias filter to remove the high frequencies that do not contribute much to the formation of the information signal. The output of these pre-alias filters are then applied to a commutator, which is usually implemented using an electronic switching circuit. The commutator performs two important operations. At first, it takes a narrow sample of each of the n input messages at a rate of fs that is slightly higher than 2w, where w can be assumed to be the cutoff frequency of the pre-alias filter. Secondly, it sequentially interleaves or accumulates these n samples inside one sampling interval. In fact, this second function of the commutator is the essence of time division multiplexing operation. Following the commutation process, the time multiplex signal is applied to a pulse amplitude modulator, the purpose of which is to transform the multiplex signal into a form that is more suitable for transmission over the communication channel. I will not dig too much into the operation of the pulse amplitude modulation. I have already created a video on this and I request you to kindly refer to that video for more information on pulse amplitude modulation. Coming back to the TDM system, suppose that we have n message signals to be multiplexed that have similar spectral properties. The sampling rates for each of these message signals can be determined in accordance with the sampling theorem. Let Ts denote the sampling period for each of the message signal and let Tx denote the time spacing between adjacent samples in the time multiplex signal. Then it's possible to relate Ts as well as Tx using the equation given by Tx equals Ts divided by n, where n is the number of input message signals. Coming back to the TDM system, by careful observation we may note that the time division multiplexing enables the transmission of n information signals within one sampling interval. Therefore, we can state that the TDM system improves the bandwidth requirement by the factor n, where n is the number of input message signals. This in fact is one of the biggest advantages of time division multiplexing. The pulse amplitude modulated version of the TDM signal is then passed through the communication channel and the output of the channel acts as the input to the receiver. At the receiver end of the system, the received signal is applied to a pulse amplitude demodulator, which performs the reverse operation of the pulse amplitude modulator. The pulses produced at the pulse demodulator output are then distributed to the appropriate low-pass reconstruction filters by means of a decommutator. It is important that the decommutator operates in complete synchronism with the commutator at the transmitter. This synchronization is essential for the satisfactory operation of the overall TDM system. Otherwise, the whole system may fail. Lastly, the use of low-pass reconstruction filters here is to remove the replicas of the original frequencies that were created due to the sampling procedure. The outputs of the low-pass filters are the message outputs generated by the TDM system. Right. With that, we come to the end of this discussion on time division multiplexing. I hope you liked this video. If you did, kindly press that like button and subscribe to my channel for more videos on digital communication. Thank you for watching. Have a good day.